These notes will be over chapter 3.1, Newton's second law. So we're going to start by talking about force, mass, and acceleration. So the greater the force on an object, the greater the acceleration of that object. So if you think of the amount of force that like a kindergartner can apply to, like, let's say a shopping cart, compared to the amount of force that you could apply to a shopping cart, okay? If you guys both push with as much force as you can, you're going to accelerate the shopping cart more than the kindergartner, okay? Because they're not able to put enough force behind it. Okay, so acceleration of an object depends on both the mass of that object and then the force applied. So they're all connected. So for example, if we have an increased mass, you would need more force for the same acceleration. So if you think about a small ball versus a bowling ball, in order to throw a small ball and to throw a bowling ball and they have the same acceleration, you're going to have to apply more force to the bowling ball because it has more mass. So here are the equations for finding or calculating the force, mass, or acceleration. Okay, and I have it solved in the different things. So if you're trying to find force, it's force equals m times a, or mass times acceleration. If you're trying to find mass, it would be mass equals force divided by acceleration. Or if you're trying to find acceleration, it would be force divided by mass, okay? Remember that force is measured in newtons, which is denoted with an N. Okay, mass is going to be measured in kilograms, and then acceleration is going to be measured in meters per second squared. Okay, so if we look at these practice problems, you're pushing a friend on a sled. You push with a force of 40 newtons. Your friend and the sled together have a mass of 80 kilograms. Ignoring friction, what's the acceleration of your friend? So we want to find the acceleration. So we're going to be using formula force divided by mass. So our force was 40 newtons, so 40 newtons divided by the mass, which was 80, and that's going to give us 0.5 meters per second squared. Okay, for the next one, a student pedaling a bike applies a net force of 200 newtons. The mass of the rider and the bicycle is 50 kilograms. What's the acceleration of the bicycle and the rider? Again, we're finding acceleration, so we're going to use this bottom equation. Acceleration equals force divided by mass. Okay, so our force in this case was 200 newtons divided by our mass, which is 50, and we got 4 meters per second squared.